Hi everyone. I thought I would just take a minute and do a quick video of myself running through this no calculator practice for your quiz tomorrow, just so you can sort of see my thought process and how I work through things and how I split things up and so on. A lot of these, there's not really like a process to go through to get your answer. It's more of just thinking your way through logically, okay? So, for example, this first one, 8 over 64 to the power of 1/3. Remember that you treat these separately. So this is like 8 to the 1/3 over 64 to the 1/3. Now, these are ones that I find to be pretty reasonable for you to get in your head. If you don't know how to do one or both of these in your head, I'll make a second video in a minute on how to find them with a factor tree. But I would expect that majority of these you wouldn't need a factor tree to do them, okay? So 8 to the 1/3 power is 2, because 2 to the 3rd is equal to 8. 64 to the 1/3 is 4, because 4 to the 3rd power makes 64. And then 2 over 4 reduces to 1/2, okay? So there's my final answer for that first one, okay? Now for the second one you'll notice looks really similar to number one. With that fraction on the outside, though, what I would do is I would split it up, and I'm going to try to fit this all in on one line here, but I would make this 64 over 8 to the 1/3 power, and then put the 2 from the top of the fraction outside of that, and then the fact that it's negative means I'm going to stick a -1 out here. And I know you might think that's a lot of extra steps, but that's really kind of giving yourself steps to walk through. I need to take everything to the 1/3 power, and then I need to square it, and then that -1 means I need to flip it over, okay? So this right here to the 1/3 power is really almost exactly the same as number one, except it's upside down. So 64 to the 1/3 is equal to 4. 8 to the 1/3 is equal to 2. And then we have that squared, and then to the power of -1. Now, I could reduce that to a 2 right now, but I sort of want you to see how to do this with a fraction, so I'm going to leave it alone, and then I'll deal with it at the end, okay? But there would be nothing wrong with reducing that to a 2 right now. If this were a fraction and I had to square it, I would square the top and square the bottom. So 4 squared is 16, 2 squared is 4, and then that's still to the power of -1. And then this -1, if I'm still sitting with a fraction right here, is going to take my whole fraction and flip it over. So it's not going to be 1 over something. It's going to be the inverse of that fraction. So that would be 4 over 16, and then 4 over 16 would reduce to 1/4. Okay, I know that's really hard to see. Sorry about that. But 1/4 would be my final answer there. Okay, and again, back here, if I had reduced this to make it a 2, 2 squared would have given me a 4, and then 4 to the -1 power would have flipped that over and made it a 1/4. So either way, it would have been the same thing, but I wanted you to see what to do with a fraction there. Okay, number 3. This might freak you out a little bit that it's decimals, but I want you to think about if 0.09, if you're looking for 0.09 to the 1/2 power, do you know 9 to the 1/2 power? Okay, 9 to the 1/2 power is equal to 3. Now, if this is 0.09, if there's 2 decimal places there, then when I take a root of it, I'm going to have 1 decimal place left, and I'll show you why in just a minute. But so if 9 to the 1/2 is equal to 3, 0.09 to the 1/2 would be equal to 0.3. And the reasoning for that is that if I do 0.3 times 0.3, that's a 1/10 times a 1/10, which would give me an answer in the 100ths place. I don't know if you remember that from when you first learned about multiplying decimals, but if you've got 2 decimal places here and you take a root, you're going to have 1 decimal place there, okay? Because you would end up multiplying that by itself, and that would give you the 2 decimal places of the 0.09. Okay, number 4. Number 4 I actually worked through a little while ago with leaving it as a decimal. And then I found that towards the end, it actually was easier if I made the 0.25 into a fraction first. This one I'm definitely going to need more space on, so I'm going to move this down here. Okay. so number 4, I would write it as a 1/4 instead of a 0.25. And then I would split up this fraction as a 1/2 and then a 3 and then a -1. So I kind of take that fraction apart. So 1/4 to the 1/2 power. Well, 1 to the 1/2 power is just 1. And 4 to the 1/2 power is a 2. Okay? So that was 1 and 4 to the power of 1/2. Then I want to cube that. All right, so now I'm raising to the power of 3. And I can't forget that I still have a -1 out here. So 1/2 to the 3rd power. Well, 1 to the 3rd power is 3. Nope, just kidding. It's 1. And then 2 to the 3rd power is 8. Raise that to the power of -1. Remember, a -1 power applied to a fraction is just going to flip it over. So it would end up being 8/1 or just 8 is your answer for number 4. Okay. If you had done it with the decimal, it would have been just fine. 0.25 to the 1/2 power would have given you a 0.5. 0.5 cubed would give you 0.125. But then this is where the issue comes in. If you have 0.125 to the -1 power, you don't want to write that as 1 over a decimal. That's just ugly and bad form. So, I mean, you could have done that and then converted it back to a fraction at the end. That would be fine too. But when you're working without a calculator, I usually find fractions easier to work with. Okay. Okay, back to number 5. Okay. If you're looking for what this equals, and I've been using x, I've been saying equals x, and then I realize we get into some down here where it's an x that you're actually solving for. So I'm not going to use an x, I'll just use a question mark. Okay. What this is really saying is 10 to the power of something equals this number. So 10 to the power of something is equal to how many zeros? 1, 2, 3, 4, 5, 6 zeros. Well, ask yourself, what power of 10 would give you 6 zeros? Powers of 10 are really easy to work with. That'd be a power of 6. Okay, and so my final answer there would just be 6. Okay, because 10 to the 6th power gives me that number there. Okay, number 6. Log base 3 of 1/27. Again, what I'm asking myself there is 3 to what power would give me 1/27? Okay, well, I know that 3 to the 3rd power would give me just a regular 27. Okay, and then I need to think about how would I make that flip over. Well, the way I make this flip over into an inverse is I make my power negative. So then 3 to the -3rd power is equal to 1/27. And so therefore my answer is -3. Okay? Because remember, that's what you're solving for, is what is the exponent that I need here. Okay. Number 7. Before I start anything, I want to think of this as a power and not as a root. And if I write this as a power, it would be x to the power of inside over outside, so it would be x to the power of 5/4. So remember, if you take this log and rewrite it, it would say x to what power equals x to the 5/4 power. Okay, that's really what I'm asking, is x to some power equals this crazy thing, and we already know what power that is. So I just need to know what question mark is. The question mark is equal to 5/4. So your answer there is just 5/4. Okay. Oh, I messed up my color coding there. That's annoying. But that's it. That would be your answer for number 7, is 5/4. Okay. All right. Onward over here. Log of 0.001. All right. I would probably, and you know, if you know, especially if you know scientific notation, you probably wouldn't need to do this, but I would write this maybe as a fraction. This is in the 10/100th thousandths place, so this is really 1/1000. Okay, that would give me 0.001. And remember, my base down here is really a 10. So what I'm really saying is 10 to some power gives me 1/1000. Okay, Well, I know that 10 to the third power gives me 1,000, okay, because that has 3 zeros. So if I want to flip that, if I want to make it 1 over 1,000, I would just make my 3 negative. So 10 to the negative third power gives me 1 over 1,000. And so my answer there is just -3. Okay. Number 9. Question I'm asking myself here is 8 to what power makes 1/8? And just like we've been talking about, I don't even need a power to turn an 8 into an 8, right? It's really a power of 1. But the fact that it's flipped over, the fact that it's a reciprocal, means it must be a -1. So that would be, this right here would have to be a -1. Okay? So again, that's what you're always looking for with those log questions, is what power turns the base into whatever it is you're taking the log of. Okay. Number 10, I think I mentioned this in class, but that 0.25, I think in this one is going to be way easier to think about as a 1/4. So really what I'm asking myself here is 4 to what power makes 1/4, which is equal to 0.25. Now this looks just like this one, right? My question mark would have to be a -1. Okay, because 4 to the -1 power makes 1/4. Okay, number 11. That's a base of 10, so I'm saying 10 to what power would give me a 1? Well, what power always gives you a 1? Okay, that'd be a power of 0. 10 to the power of 0 equals 1, so 0 would be my answer there. Okay? All right, number 12 is a little trickier. So number 12 is saying 8 to what power is equal to 16? Okay, now we don't have a power that turns an 8 into a 16. So what we're going to have to do with this one is we need to write these both as powers with the same bases. So I need to write them both as a power of something else where it will match. Okay, I know that I can write, I'm going to go ahead and use an X on this one just so that it looks a little more technical. So 8 to the power of something gives me 16. Well, I can take 8 and write it as a power of 2. So I can make this 2 to the power of 3. So 2 to the power of 3 is my 8. And then I've got an X, so I'm going to tack an X onto my 3. And then 16, I can also write as a power of 2. 16 is equal to 2 to the 4th power. Okay? So now I know, because I've got the same bases on them, 3x must equal 4. And then I just solve for x. I divide by 3 on both sides, and x is equal to 4/3. So that there was your answer to number 12. Okay. Okay, 13, I might slide down here for just because I'm running short on space. So 13 says log base x of 2b plus 7 equals log base x of b. Okay. You have a log base x on both sides, okay, which is going to allow you to cancel those logs out, but maybe not for the reason that you think. I have a lot of people who say, well, but it's because you're dividing by a log on both sides. You're not dividing by a log because the log is not being multiplied by this, so you're not dividing, okay? But this would be as though, and this is not part of the actual problem, but just conceptually, if I knew that x plus 5 was equal to y plus 5, okay? I'm doing the same thing to both of them, right? I'm doing the same thing to this side as I am to this side. So that tells me that the things that I started with, the x and the y, must have been the same thing, okay? So up here, I had these two things, and I took the log of this side and the log of that side, and they came out the same. That must mean that these two things are the same, okay? They have the same log. So I can just say 2b plus 7 equals b, okay? And then solve that for b, just like a regular equation. So I would subtract 2b from each side. So I end up with 7 equals negative 1b. And then I'm going to get rid of this down here. Divide by negative 1, and I end up with negative 7 equals b. And that's what you're solving for there. That's your final answer for number 13 would be negative 7. Okay? And then number 14. 14 is asking 9 to what power is equal to 1 over 81? Well, I know 9 squared gives me 81, and then to make it a reciprocal, I would have to make it a negative. So 9 to the negative 2 is equal to 1 over 81, and so this is my answer that I'm looking for there is negative 2. Okay? That made kind of a mess of my paper, but hopefully you were able to follow at least some of that. If you do have more specific questions, you're welcome to ask tomorrow or post a comment or whatever, and I'll get back with you. But I hope just kind of walking through that gave you an idea of what I'm asking you to do here.